Last lesson for this week, and the easiest one by far of everything we've done in chapter 5 so far, is called solving rational equations. So back to rational equations, the idea that a rational function is any polynomial over a polynomial. And they can be of varying degrees, we remember from 5.2. Making it a rational equation just means somewhere an equal sign is going to show up. So it may equal 0, it may equal another rational expression. And when we normally teach this course, we teach two different methods for solving. One a little more complicated than the other, but we decided this year, based on the circumstances we're in, that we're just going to teach the clear the fractions method here. And in the next lesson, we'll go over finding a common denominator, which people tend to struggle with a little bit more. So there's two parts to the clear the fractions method, and I really probably should have listed this first. The first thing you have to do is state any restrictions. So if you go back to our days in grade 11, when we first started looking at rational expressions, you'll remember we want to avoid the denominator equaling 0. So in all of these examples, before you do anything, you just want to state any restrictions that might exist. So here we want to make sure x doesn't equal -3, because if x equals -3, then the denominator becomes 0, and we know we can't divide by 0. Somewhere like here, we want to make sure x does not equal -7, and here there happens to be two restrictions. We want to make sure x does not equal 4, and that x does not equal -2. So before you start any question, stating the restrictions would be the first thing you want to do. Okay, and then on the other end, the clear the fractions method works like this. We want to get rid of the rational. That's the whole idea. We want to turn it into just a polynomial equation. So in order to undo something, we do the opposite, and that's the way we started solving equations when we were in grade 9. So right now, it's basically the rule is if you see any polynomial in the denominator, so here x plus 3, here x plus 7, here there's an x minus 4 and an x plus 2. In order to get rid of this division, we have to multiply every term in the equation by that exact thing. So if I want to get rid of a division by x plus 3, I need to multiply by x plus 3. If I do it to this side, I have to do it to this side. What that does is allow this to cancel. Remember, it's the same as saying x plus 3 divided by x plus 3 is 1. Anything divided by itself is 1. We've gotten used to this idea of canceling, so we just go crazy and cancel. But the idea is that canceling is really a division that equals 1. So all you're left with on this side is the x minus 2. And then on this side, 0 multiplied by anything is 0. So then when you go to solve, you bring the -2 to the other side, and you simply get x equals 2. Okay? Remembering that this restriction existed. So x equals 2 in this scenario, remembering that x could not have equaled -3. If you happen to get an answer that is this, that's going to be a problem. That can't exist. Okay, when you go down to something that looks a little more difficult, because there's rational expressions on both sides of the equal sign, you just have to do that step twice. So the idea is to get rid of the x minus division by x minus 4. You multiply by x minus 4. What you do to one side, you do to the other. These cancel. So all you're left with here right now is x plus 3 on this side. On this side, you have x minus 1, you have x minus 4, all divided by x plus 2. So then you're saying, okay, it's looking better. This side is simply a polynomial. This is still a rational function. So how do I get rid of the x plus 2? The same way you did before. To get rid of any denominator that's a polynomial, you're going to multiply all parts of the equation by it. So this will cancel in this case, leaving you with x plus 2 times x plus 3 on this side, and leaving you with x minus 1 times x minus 4 on this side. So you have done the goal. You've cleared the fractions. Now it's just a matter of distributing that out. This is a binomial by binomial, so you'd be using the FOIL method, gathering like terms and solving. So I'll just do it quickly. X squared plus 5x plus 6. This side, x squared minus 5x plus 4. Bring everything to one side of the equation. So you had an x squared, you bring the other x squared over, it becomes negative. The negative 5x comes over and becomes positive. Plus 6 minus 4. These cancel. 10x, oh sorry, that's going to equal 0. 10x plus 2 equals 0. Bring the 2 back to the other side. X equals negative 1/5. Okay, so you can kind of take a look at that. It's worked out for you in the solutions or in the worksheet as well. But once you get to this step, it's a matter of preference on how you want to solve it. So I originally brought everything to one side thinking I was going to have to factor this. Then in the end, it just set up as a linear equation. So I just set it back up and got a fraction answer. Okay, in C, we've already made our restriction here and everything looks like it's going to be an easy question. Follow the same rules to get rid of an x plus 7. We're going to multiply both sides by x plus 7. This goes away. And then when everything comes down to it, you say, well, 5 equals, well, what's 0 times anything? 0. This is a big unknown. No solution. Who's out here?
Me.
Hey, buddy.
Morgan's not cleaning the thing with me.
She's not cleaning what?
The fireplace.
Only your toys are getting cleaned up?
What?
Only your toys are getting cleaned up?
No. Morgan cleaned up hers, but I told her to help mine because I have heavy things. I need Morgan to help me.
Okay, you want to come say hi? Or just stand behind the camera, I'm filming. Come on this side. Say hi. We don't see you very often, boy.
I'm here now.
Okay. Well, what kind of heavy, you don't have heavy stuff.
You sort of.
Bring your Lego to your Lego table.
But she needs to help me.
Okay, well ask her. You guys sort it out.
I told her and I yelled at her and she said, no, you go punk.
Maybe it's because you yelled at her.
Yeah,
Like,
I'm writing
that's
her
not-
and calling her punk.
Okay, well, we're all punks. We've all been stuck at home too long.
She's the most punk.
Okay.
Ish. A lot punk.
Okay. All right, 2 more examples. One I'm going to add in that wasn't originally in the lesson. So I'm
Can
going
you
to call it.
just tell her if she comes in that her iPad's going to get taken away if she doesn't do what I say?
No, you're not the boss.
But I want to be
You
the
clean
boss.
up your stuff, she cleans up her
I'm
stuff.
older than her.
Okay. The next example that's not in there that I wanted to make sure we kind of looked at. I'll talk to her, but
I'm
no,
going
you're
to
not
go
the boss.
tell her if she doesn't clean up, she gets her iPad taken away.
No, she has to clean up her stuff. You have to clean up your stuff. Sorry. Okay, so when we look at an expression like this, which I've added one that's a little more complicated. This one now has a constant term. It again has 2 rational expressions that both have polynomials in the denominator. So I again want to say clear the fractions, and sometimes you can do it in one step if you want. The idea is to get rid, maybe just do it slowly. If I want to get rid of a division by x, I multiply by x. Well, I can't just multiply this. I have to multiply all terms of the equation. So this has to be multiplied by x. This has to be multiplied by x. The only thing that cancels is the one that you were attempting to cancel. So then you write the next step. 3 is here. This is now 4x, 4 times x, or x plus 1. On this side you have 2 times x, which is just 2x. So you've cleared one of the fractions. To clear the other fraction, you do the exact same thing. I want to get rid of a division by x plus 1. I need to multiply by x plus 1. But I need to multiply everything by x plus 1. There are currently 3 terms. All of them have to be multiplied by x plus 1. The one you were attempting to get rid of goes away. This is now, really, you can write it in any order. 3 times x plus 1 is how we're used to seeing that. This is 4 times x. And on this side, we have 2x times x plus 1. That's the main stage, clearing the fractions. Don't forget, way up here, that you have to make sure you state the restrictions. So before I did anything, I should have said x cannot equal 0 or negative 1. He's not the boss of you. You're not going to get your iPad taken away. Well, if you can help him. I know, but if you can help him, that's fine. If not, then don't. It's his stuff. He can clean it up. Thank you.
Don't want it.
Okay. So we do have to. Okay. We do have to state these restrictions. We do have to state these restrictions, and then from there, it just becomes a quadratic that you can solve. So we want to multiply it all through, collect like terms, and then decide what the best way to solve it is. So this becomes 3x plus 3 this one here becomes 2x squared plus 2x. Now, again, it's totally up to you how you do it. I'm going to leave this side 0 because this term is already positive, the squared, so I like that better. I'm going to leave that there. You have 7x over here. When you bring it to the other side, it becomes negative 7x, and you had a 2x. So 2x minus 7x is negative 5x. You have a positive 3 here. When it goes to this side, it becomes negative 3. By quick inspection, you can see that this is, in fact, factorable. 2x and x, and then negative 3 and positive 1. Right? They multiply to negative 3. Then when you do the inside, 1x, outside negative 6x, that's negative 5x. You'll remember the zero product property that says if two values, a times b equals 0, then either the first one equals 0, or really or the second one equals 0. Okay, so when we solve this, 2x equals negative 1. I obviously don't have to go over that. X equals negative 1/2 on this one. X equals 3. Okay, so, I mean, clear as day, this is not a difficult lesson at all. It's just a matter of clearing the fractions and then solving. And can you basically solve either a quadratic or can you solve a linear function? If you get one that's cubic, then do synthetic division. Quartic synthetic division, you know. Linear, just solve. Quadratic, use the quadratic formula or factor. Anything above that, use synthetic division. Okay, example 2 is the only one that's a little bit tricky. There's actually a well thought out explanation in the note where it explains it fairly well for you. The scenario, if I can find the question sheet, basically says a guy bought a case of concert t-shirts for $450. So, you know, he got a big box, a bunch of t-shirts in there. He kept 2 t-shirts for himself, so he took 2 t-shirts out, put them in his house, and then he sold the rest online, say. Okay, so he sold the rest for $560, making a profit of $10 on each shirt. How many t-shirts were in the case is the question. So in order to answer a question about profit, you need to know a little bit about, I guess, accounting. And we've done questions like this before. So a couple things. Profit is your revenue, so how much money you take in, minus your cost. Okay, so you can't take into, you're only making profit on the difference, right? Like, it's going to cost you so much to produce something, and then you'll sell it for a certain amount, and your profit's just that the amount of money in between that. So in this situation, he's only going to profit whatever he makes minus what it cost him to get them. So in terms of the question, when you look at it, it says how many t-shirts were in the case. So we're going to say something like, let X be the number of t-shirts in the case. Okay, so X is the number of t-shirts, and you'll remember doing questions like this previously. Now we're going to have to sort of adjust our statement in a way that we want to say, because we're looking for t-shirts, we're going to say profit per shirt is the same as revenue per shirt minus cost per shirt. Okay, so this is going to help us out because we're taking the same sort of equation, but now we're going to deal with individual shirts. So it says right in the question, he makes a profit of $10 per one shirt. His revenue, and this is how much he's bringing in, he says he sells it for $560. However, the number of shirts that are in that box is X minus 2, because remember, he took 2 out for himself. So imagine there was 50 shirts in the box. Originally, he took 2 out, so it's $560 per 48 shirts. So you had to take into account something like that. And then the cost is how much he spent. So he spent $450 for X shirts. He got all the ones in the case, he took 2 out, and then he went from there. So this is by far the most difficult part of this question. Once you've established this part of the question, it just turns into a normal question. Now, $10 per one, we should really take the dollar sign out. It's just 10. This is 560 over X minus 2, and this is 450 over X. Now, to make things a little bit easier, instead of clearing the fractions in 2 steps, just clear them in 1. So not only do we want to get rid of the X, we want to get rid of the X minus 2. So we're actually going to multiply by both of those things. X times X minus 2 on this term, x times x minus 2 on this term, x times x minus 2 on this term. And what that does is set up a double cancellation. So nothing cancels here. The x minus 2 goes away there. That makes us happy. The x goes away here. Remember, it's just a division that equals 1. And in the end, we can deal with this. This is, multiplication's commutative. It doesn't matter what order you do it in. So we'll do it in the order that we like better. 10 times x minus 2. On this side, we're just left with 560 times x. And here we're left with 450 and the x minus 2. Now it just becomes a simple quadratic, and you can choose how to solve it. So basic distribution from grade 9, 10x squared minus 20x. Distribution here too. Okay, and again, this is already positive, so I'm happy with it on the left side of the equation. I have negative 20. This here is 110x. If I bring it to the other side, it becomes negative 110, and I have negative 20, so it's negative 130x. Bring the 900 over. It also becomes negative. This is looking nice and factorable. I'm going to common factor a 10 out first. And now really you're just looking for a situation. Are there two numbers that multiply to negative 90 and add to negative 13? So depends how good you are with numbers. But 18 times 5 is 90. And then you just get the zero product property again, where you simply look at this and go, well, if these two things multiply together to be 0, then one of them was equivalent to 0. Sorry. And it's glaring which one is. The answer is either x equals 18 t-shirts or x equals negative 5 t-shirts. Did you buy a box with negative 5 t-shirts? No. Makes no sense. That's what we say, inadmissible. I think I spelled that wrong. Inadmissible? No. Okay, so the answer is really 18 t-shirts. So in the end, you're going to be very official. Therefore, there were 18 t-shirts in the box. Okay, which is the question they were asking. So if you weren't aware of this formula, you are now. There's a couple word problems in the homework, but mostly it's just practicing clearing the fractions. This is a nice break from 5.1 and 5.2 that had a lot of graphing and was a little more labor intensive. So hopefully if you got through 5.2 and you're tuning into this one, you're feeling a little bit better about this. Okay, that's as far as we're going for the rest of this week, and we'll tune back in on Monday, which I honestly don't even know what day to say. 22nd maybe? So maybe Monday's the 27th, I guess. So yeah, if you're watching this before the 27th, you're good. If not, you're behind. Okay. Sorry about my children. Life.